Okay, so what I want to do is stop sharing the screen and share a whiteboard. And the first thing that I want to point out is, um, well, so we want to analyze this consumer's choice problem or the consumer choice problem. And it turns out that rationality can get us pretty far in recognizing how consumers will make choices. But um, remember that we have really, uh, under the consumer choice model, we have two things we're considering. One is affordability, and the second one is preferences. And so let's explore affordability, and we'll go ahead and graph the consumer's um, budget generally. Now, I want to point out that it doesn't matter which good you put on which axis. Um, and there's a couple of other things worth mentioning. So I'm going to put the quantity of good X on the horizontal axis and the quantity of good Y on the vertical axis. And I'll start just using Y and X, but I want to emphasize that it's quantities right now. And then obviously here at the origin, we have our 0. And I'll come back to this in a minute. And so generally, the consumer's budget, and you'll see it really kind of depends upon the context. Um, so the budget is the amount of money that the consumer has to spend on goods, right? Um, but sometimes that's referred to as income. And you could also think of it as disposable income. And one thing that confuses folks sometimes, but again, it's context dependent. You have to pay attention. Sometimes it'll just be Y, which can be confusing if you think of Y as being a good. It's just a good you're graphing on the Y-axis. Using capital Y in a lot of contexts means income in economics. So if you think about GDP, where Y is equal to C plus I plus G plus net exports, then Y is a symbol that's often used for GDP, which real GDP is a measure of national income. So hopefully that'll make some sense to you. You have to do it on the basis again of context. A lot of times, what folks do is they don't deal with good X and good Y. They'll just deal with good X sub 1, X sub 2, X sub 3, and then you can have an infinite number of goods if you do it that way. So what I want to emphasize, though, if we use budget, and I use B for budget, and again, in most contexts, that's clear. You'll see later on, I switch to I for income. But so our equation in the case that we have two goods is that um, the budget is going to be equal to um, the sum of the spending on the two goods. Here, if our two goods are X and Y. Okay. And so as not to confuse you and make sure that you understand I'm talking about good Y and not the amount of income, I'm going to go ahead and erase that there. So that was just a heads up. So yeah, so the price of X times X plus the price of Y times Y. This is what we would call the consumer's um, budget line, or sometimes you see people call it the budget constraint. Now, again, I want to talk a little bit about the language because in all of these applied math disciplines, the math generally isn't a challenge itself. It's understanding what math uh, attaches to which keywords in a particular problem to be able to solve it. So one way of thinking about this is, and if you just think about it, it's common sense, right? So if this is your budget to spend on goods and services, then it has to be true that your budget is greater than or equal to your total expenditure. And I will tell you that the consumer optimization problem is implemented using uh, constrained optimization technique we'll call utility maximization, right? But it's true also that there is an equivalent formulation in terms of expenditure minimization. So, and actually, you can use either technique. And again, it's sort of context dependent, whether you want to talk about the consumer maximizing their utility or you want to talk about the consumer minimizing their expenditure to achieve a certain level of utility. It's just you're switching the role of the constraint and what you call the objective function in the optimization problem. So, um, but throw it out there because this should be sort of transparent that this is really the constraint that the consumer faces. They have a budget and they can't spend more than that budget. So it's important that um, when you look at this problem, you can see that the expenditure side of it is what's on the right hand side in the equation that's above. Okay. This is the consumer's total spending on the two goods. And I also, to show you, because a lot of times, if you think about it, this is a prediction. Our model is going to give us a prediction of how consumers are going to spend. So it's a prediction about human behavior. And everybody in this class, aside from general curiosity, should also be generally sort of suspicious, um, just like you would be maybe in a psychology or sociology class if they say, oh, or anthropology, this is the way people behave. Then you should do a little bit of introspection and think to yourself, well, is that really true? Is that how I behave? And under what circumstances would it describe my behavior, and when wouldn't it describe my behavior? Is this, for lack of a better um, um, way of formulating the question, is this a true description of human behavior? That's important, right? Because this is supposed to be science, and in science you're supposed to come up with models that generate predictions that actually match um, what we see in reality. So if you're not suspicious or at least curious about what's going on, then I would say it's probably time to tune in because and pay more attention and kind of let that curiosity drive your interest in what's going on, because if you don't, then a lot of what's going to happen as we go through all the details of explaining the consumer optimization problem is going to be lost. Now, it may be true at the end if you don't kind of follow all the arguments that you can still um, solve the problems at the end. But as soon as you hit a novel situation, so something that's not well described by the theory, um, or I should say not well described by the standard theory that you're exposed to. As soon as you see a new situation, if you don't pay attention to the details of these arguments, then you won't have any guide on how to approach that problem in a way that's consistent with what we're learning now and consistent with theory more generally. So that's just my pitch for the importance of, if you want to be a good economist, um, you know, you can solve the simple problems here, but if you're going to be working on your senior um, seminar thesis paper project, um, if you do a little bit of exploring outside the box of what you've seen in your classes, you'll realize that there are some situations where this question is interesting, but it doesn't really fit clearly into the standard problems that we saw in class or that we demonstrated. So I think these types of standard problems fit a lot of situations, but but if you pay attention to the arguments we're going to go through now, then you'll be more flexible and be able to deal better with situations that are different than what you've seen before. So okay, you can't spend more than your budget, and I just also want to show you really quickly one of the things that you should be curious about is, well, is there something suspicious going on because we're just dealing with two goods? And as I said before, you can reformulate this. So there's the price of X1 plus um, the price of X2 times the amount of X2 you'd purchase plus the price of X3 times the amount of X3 you'd purchase plus dot, 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 um, the price of Xn, which is some big number, right? Um, times the amount of Xn you'd purchase. So the point is that this model is flexible enough to deal with any number of commodities, goods that you might purchase. So we deal with just the two good case because it's an introductory way to begin our analysis where we can generate these really nice graphs and so forth. But one of the things that you should notice is that the original equation that I gave you up here, this is a description of a linear equation in general form. Okay, so you might have seen this, or I know you've seen it, probably in ninth grade or something like that. And so there's a coefficient a times x plus b times y is equal to some constant c. So again, hopefully nobody here gets confused because I write certain things on the left and the right, but it's all equal. So this is a linear equation in what they call general form. And most of the time that we want to do graphing, right, you want to put the equation, the linear equation, in slope-intercept form. So the slope-intercept formulation has all of the information to make your life easier when you want to graph something. So I'll say good for graphing. And so here, right, since we know we want to graph y on the vertical axis, then we're going to go ahead and solve this equation. Make sure you all follow my algebra if you don't. So if I mix things around, hopefully I don't need to show the details. but I'll ask you, Arsenio, you still there with me? Arsenio? Oh, maybe I lost Arsenio. Derek, are you there?
I'm here. Sorry about that.
Oh, okay. I just want to make sure that you follow my algebra. Not you specifically,
Right.
but whoever's watching out there. Okay. Does that look right? Okay. What about you, Daniel? Do you agree with me?
Probably.
Probably. Again, your confidence. What about you, Derek? Sonica?
Yeah, I'm following you.
What about you, Sonica?
I'm kind of confused with the why is it times X? But I'll
What,
follow along. It's okay.
which part? This part?
Yeah, like I'm just trying to follow along, so I'm just reading what else you wrote.
Okay. Okay. So I put this here because um, I want to communicate to you all that we can take the equation in this form, which is a very intuitive one because it just tells us that the budget's equal to our total expenditure, and we can easily just solve for y, put y on the left-hand side of the equation, and then we get the equivalent um, equation in slope-intercept form, which again is good
Oh,
for graphing.
yeah, I got it now. It's kind of just like doing like y equals mx plus b,
Yeah,
essentially.
yeah, this is the, yeah, you can,
And
and this is the general form, and you're right.
mhm.
So the standard way that people write this, and this is kind of a little bit irritating to me because the um, things get blocked on my screen when I'm trying to write. But let me go back to here. Yeah. So what the way that you've seen this written is um, y is equal to m times x plus b, right? And we're doing the same thing, but here m is negative, and we're putting the vertical intercept first. Okay. So the only difference between these two things is m can be positive or negative, and I'm just writing b first. So, um, but well, actually, I'm going to write a lowercase b so you don't get it confused with budget. Does that look good, Sonica?
Yeah.
Well, you're laughing, but I'm I'm concerned. Like
No, 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 don't be concerned. Yeah. It just takes me a little bit because like it's kind of early. So
oh,
just like
see,
reading, that's why I'm like slowly reading through it. I'm like, okay, keep your eyes open. What is it saying exactly?
yeah, see, actually, for me, it's better for me to do math before noon.
Oh, really?
Like first thing in the morning, if I want to do anything kind of technical and or detailed, my mind is much fresher in the morning. But I think that's a function of age too. I can tell you that probably when I was your age, I was doing a lot of math around midnight. So
No,
yeah,
I understand that. I'm towards my second class before noon, which is like a finance course. I'm like, okay, I can do this, and it makes sense. It's just
okay.
I don't like being awake early. That's it. But yeah,
Okay,
I get what
yeah.
you're saying.
Okay, good. Is there anybody that doesn't see what I'm saying or has any questions at this point in time? Okay. All right. So now I'm going to go back and I'm gonna do this, um, or I'm going to take this equation and in just this general algebraic expression, and I'm going to graph it, right? And so let me get a different color here. And so there's one point and another one. Okay. And so this obviously, this is going to be the vertical intercept of our linear equation, and down here is going to be our horizontal intercept. And again, what we have is y is equal to b divided by the price of y minus px divided by py times x. Okay. And so that means this point generally will be b divided by py. And as some of you mentioned before earlier, one interpretation of this value up here is that it represents the maximum amount of y that's affordable to the consumer. So if the consumer spends all of their budget on just y, then you take the budget, you divide it by py, and that's the maximum amount that they can purchase. Likewise, down here, this point, if they spent all of their income on just purchasing X, we'd have this horizontal intercept is going to be the budget divided by the price of X. Okay. And let's see. And then the line connecting these 2 points would be the consumer's budget line or the budget constraint. And then we also want to know that, and let's see, this line has a slope, and the slope from the equation generally, right, is slope is equal to minus px divided by py. So again, we're just describing what's affordable to the consumer, and the trade-off that the consumer faces when they have these prices, px and py, and they have a budget that's known, some amount of money b. So the next thing to notice is that as you move down, right, the slope tells you for each additional unit of X, which is going to be the run, right, how much Y the consumer has to give up purchasing, assuming they spend all of their money on X and Y. But even if they didn't, how much, given the prices, how much Y they have to give up to purchase an additional unit of X. And this is kind of an important point. We'll talk about it later, but this, opportunity cost of additional X, and then notice, obviously, right, the inverse of this would be like if we flipped the axes, right, then we would have the multiplicative inverse of this slope, and so it'd be py over px, and then that would tell us for each additional unit of y how much X the consumer had to sacrifice in terms of what they could afford. So there's information here about what sometimes we call the relative price of X, the relative price of the good on the horizontal axis, and the inverse of it is the relative price of the good on the vertical axis. So, as you're going through the questions, or you face other questions, just having those interpretations down is important. Now, I wanna point something else out too. And that is, let me see if I get some other colors here. That the consumer can afford to purchase any, and I'll say one other thing first by way of explanation. I'll use the little spotlight here. So let's see. Ricardo, are you there?
Yes.
Okay, so Ricardo, can you see all of these points? And this is actually just a positive quadrant of the Cartesian plane. I'm highlighting all different locations here.
Yeah, the dots do appear when you click, but they don't stay.
Yeah, right. So all of these points, right, are what we would call the consumer's consumption space. It represents all the possibilities, right? Affordable and not affordable, right? If I pick some point, can you see that point there?
Yeah.
It's way outside the
Yeah, it
budget
would be
constraint. It's so,
unattainable.
yeah, it's unaffordable,
Unaffordable.
rightable. Yeah. I mean, the reason why I kind of try to be precise with the language is because affordability relates to how much money you have. Unobtainable kind of sounds sort of metaphysical. I mean, like that there's some reason that it's impossible for you to ever get that under any circumstance, and that's not true, right? I mean, if your budget was expanded, then it would be affordable, right? So these things are way out here. They may be desirable, and it may be that under some circumstance the consumer could purchase those combination of the goods. But also, I'll say one other thing, Ricardo. When I put a point here as a location, you see that, right?
Yes.
You understand that location gives me a value on the X and Y axes, right? It's an address, just like sometimes they call it an address, where you have an ordered pair like X and Y. You understand what I'm talking about?
Yeah.
Right? And that address gives me a quantity of each of the goods, right? It's so let me put a point here. So if I put a little point out here, then and I'm just gonna draw this really quickly. The address of that gives me an amount of X, and it gives me an amount of Y. Do you see what I'm talking about?
Yeah.
Right? And so it's typical in economics to refer to these points in the consumption space as consumption bundles. Okay. And I don't know, is that language sound okay to you? Or do you have any, if I say this is a bundle of X and Y, this is a bundle of X and
Yeah,
Y,
that makes sense.
and this is a bundle of X and Y, right? So each of the points of the consumption space indicates a bundle of X and Y. Some are affordable and some are not affordable. All the ones that are, either on this line or below the line are affordable to the consumer. The difference is that the ones that are on the line represent consumption bundles that require the consumer to spend all of their budget, right? Do you follow me, Ricardo?
Yeah.
And if they choose to consume a bundle that's inside the budget constraint, it's affordable, but the consumer would have additional money left over in their budget that they could spend to buy more of those goods. Does that make sense?
Mm-hmm.
Okay, good. So I'm gonna go ahead and delete that and delete that so as not to mess up our graph too much. So the next little bit of language that I want to talk about, and so the affordable set, and this is sometimes also called the budget set of the consumer, right? That includes every consumption bundle on the budget constraint and I'll say below it. Okay. So how do you feel about that definition of the affordable set, Ricardo? Are you good with it?
Yeah.
Okay. Yeah. So all I'm saying is that all of these points down here are also affordable. And so that relates to this definition here, that when we're talking about the budget set, the only difference is that for this equation here, we would change this from an equal sign, which gives us the line, to a greater than or equal. Okay, if we're going to talk about the entire budget set. So the budget set is an inequality. And let me see. So B is greater than or equal to px times x plus py times y. And the budget constraint, and I'll put it over here. Constraint.
When you're putting an equal sign next to the greater than, do you mean greater than or equal to?
Yeah, I just don't have that sign on my keyboard. So yeah, greater than or equal to. Exactly. And the budget constraint is just the same thing. Let me see if I can grab it. Okay. So hopefully the language is clearer now. We can either talk about the whole budget set or the affordable set, and what's beyond the budget constraint is the set of unaffordable consumption bundles. And one of the other things you could say, which would be fine to say, is that the budget line or the budget constraint divides the consumption space into an affordable and an unaffordable set, right? So And okay, so Daniel Grun, do you follow me? Are you there, Daniel?
We're still gonna go with probably.
Oh, come on, Daniel. Are you still telling me you're not totally good with this?
No, I just answer probably to a lot of things.
Oh, okay. Well, I guess it depends upon when you say probably, how probable is it that you're following me? Are we talking close to 1, or is it, or at least
Yes.
are we hitting like, 0.97 or better in terms of your probableness?
Just very bad at working indefinites.
Okay. Well, when we live in a world where, quantum effects are real, I sympathize. Nothing's absolutely certain. That's true. But I guess the other point I wanted to kind of I don't know if there are any other mathophiles out there besides myself, but when we talk about these things, one of the things that I like is that there are some deep connections to higher mathematics. When we talk about, and I'll just say this for a minute, and it's okay if you don't follow, but when we talk about this consumption space more generally, and we were to talk about the general form of this linear equation, so the one where we have multiple goods, x1, x2, x3, this is going to be a hyperplane dividing um, uh, uh, linear subspace of potentially, countably infinite dimensions. So there's a lot of even though we're doing stuff very, very at a simple level here, there are a lot of connections here that makes our analysis flexible and robust to doing things that are much more realistic and complex. That's the only thing I wanted to point out by talking a little bit about it more generally. So we have points here that are consumption bundles that are unaffordable, other ones that are affordable, and some that are exhaust the budget of the consumer. So I also will say here that consumption bundles on the budget line exhaust, meaning they cause all of the consumer's budget to be spent, exhaust the budget of the consumer. So now let's talk a little bit about what we really want to do. So again, we've only, and hopefully everybody is fine with this and is clear, we've only talked about the issue of what's affordable and not affordable. And from that, we've half solved our problem, right? So the problem is trying to predict what the consumer will and won't do. And I'll mind you, right, or remind you that when we talk about things like the law of demand, right? Are you with me, Sonika? Everything good?
Yeah, everything's fine.
Okay. So talk with me a little bit about the law of demand. Okay. So the law of
Okay.
demand tells us, right, as the price of a good increases, consumers tend to buy less, right?
Hmm.
And then notice if we increase the price of good X, what's going to happen to our budget constraint is it's going to rotate inward, right? The total
Yes.
amount of X that we can afford is going to go down, right?
Mhm.
So you can see this ratio here. B is some number. It's fixed. It's a constant number. And if PX increases, then it's going to cause this point to move toward the origin, right? And we get this steeper budget constraint, right? And
Wait, isn't in this situation P of X decreasing? Or,
well, if
or
so P sub X is the price of X, right? So
yeah.
if the price of X increases, this whole
Oh, okay.
ratio goes down.
Yeah, I get what you're saying. I understand, yeah.
Yeah, because I mean, all we'd have to do to make it a little bit more concrete, right, is we put in some numbers. B is equal to $100, right?
Yeah.
And then price of X is equal to 2, right? And then have the price of X increase to the price of X is equal to 3, right? And then have it change again and have the price of X equal to 4, right? So if that happens, then originally, right, we would have, you could purchase 50 units, right? So I'm saying if the price of X is equal to 2 here, right, then I can at most afford 50 units of X, right?
Yeah, what happened was like I'm so used to thinking of PPFs, and so I'm so used to just feel like not like just seeing like a regular price or regular quantity on the ground, I mean on the x-axis, and not thinking of B divided by P sub X. So
Yeah,
that's why I was like, wait a minute, isn't it going lower? But I get what you're saying that
yeah,
I get what you're saying, yeah.
yeah. Okay. And what about you, Derek? Are you fine with this? I think you probably are.
Yeah, I'm good.
Yeah. Anybody else have a question? So I'm just pointing out that this budget line, if I increase the price of X, would rotate inward. And if I
Mhm.
lower the price of X, then the slope is going to get lower, not steeper, right?
Yeah.
So it's going to get flatter. And if I change the price of Y, if I increase Y, then it's going to get flatter that way. And if I decrease Y, then it's going to go up, right?
Mhm.
So, and it's going to change our affordable set. So I said, so let's talk about the law of demand, and you can figure out a lot to do with the law of demand. But one of the things I point out to students is that, hey, listen, even if you say that the consumer um, has some good that's absolutely necessary. So the example I like to use is insulin, because my mom is an insulin dependent diabetic,
Mhm.
and to be healthy, to survive, she needs her insulin. So you might imagine, well, gosh, and also the law of demand is a little bit subtle. The law of demand only says that demand curves can't slope upward, right? So as you increase the price, it doesn't actually mean consumers have to purchase less. It just means they can't purchase more. Okay, so it's actually an inequality, and a lot of people forget that, but that's actually what the law of demand is. It says the demand curve has to slope downward in what we would call weakly sloping downward, which means that it could be flat and then at some point go down. But
Mhm.
even if consumers, like my mom, she needs her insulin, you raise the price, she's going to keep purchasing the same amount she needs to stay healthy. At some point, you're going to make it so expensive that she literally can't afford to purchase what she was purchasing before. So the law of demand um, is true if you consider the consumer's budget issue too, right? That if you make the price high enough, it's not that they don't want to purchase the insulin. It doesn't have as much to do with their preferences, but this issue of affordability takes over, and they just can't afford to purchase as much as they did before.
Yeah.
So in that sense, the law of demand is it gets beyond the mere prediction of how humans will behave when they have a bunch of choices available to them, but gets down to what's possible when you start to raise prices such that goods become unaffordable. But again, there are two issues here, and we're going to find in a minute the consumers' preferences matter too, but we just haven't gotten there. We've just been talking about this issue of affordability. But I wanted to point out that affordability does affect the budget constraint in different ways, as we just saw. One of the thing, and also relate to this prediction of the law of demand, that as you raise the price, eventually consumers just won't be able to afford as much, so they'll have to decrease their quantity. But I wanted to point one other thing out really quickly before we move on, which is, notice that if, are you still with me, Sonika?
Yeah.
If I increase the price, or excuse me, if I increase B, just have a greater budget, and I hold the prices constant, then this equation that describes the budget, and I'll use this one for the budget set, or we can use this one that we graph, the slope intercept form. But if I increase B, that I'm just going to get a parallel shift outward, right? The slope is not affected. So here, notice the slope is still just determined by the prices. It's only the vertical intercept that's changing.
Yeah.
And so I can show a change in the budget, and obviously I'm not changing the length of the line segment that I drew. But yeah, just changing B is either going to be a parallel shift out of the budget or a parallel shift in of the budget. Okay.
And that increases the budget set if
Yeah.
you go outwards.
Yeah, if you go outward, then the affordable set of the budget set gets bigger, and obviously, if you decrease the amount of money the consumer has, decrease their budget, then their budget set's going to shrink. They can afford fewer consumption bundles.
So I had a question.
Go ahead.
Wouldn't you say that most items, like most goods, are somewhat inelastic, like the price and everything, just because of the fact that, like, let's take the insulin example, right? That's a very problem. That's a huge problem that's happening right now, where these pharmaceuticals are increasing prices on insulin, and then we look at other countries and the prices are very, very low because they need people to afford it. And then we've seen that at some point people don't care about the price. Like, they care, but they're like, I need this. But then at a certain price point, they're just like, I can't afford this. I need to eat, or I need to pay my bills, then take insulin. And then that whole problem with insulin happens. So I was wondering if that's true, that like at some point there's inelasticity in terms of like the price compared to how, like, the good, but then at some point that inelasticity goes.
Well, I guess it depends.
Yeah.
You sounded very passionate. I like and to be really clear about it, I think the reason why I ended up going to graduate school in economics is because I was really passionate about public policy, and economists have a lot of opportunities to participate in shaping policy and analyzing these I'll just call them social problems, but at a societal level, problems of resource distribution. But what happened in grad school is I got less interested in public policy and more interested in math. So, but that, I'm not saying that happens to everybody, but for me, I realized that a lot of these situations, there's always a trade-off. So you were talking about different societies, and maybe they'll make certain goods more available and other ones not, but then you look at their society, and I don't know if have you lived any place else in the world, Sonika?
Yeah, I lived like a year in India when I was like 1, but
Okay, you don't remember
yeah,
it
I've
then.
mainly lived in California for all my life.
Yeah. So me too. I was born in Huntington Park Hospital. I'm California, born and mostly raised.
And raised.
I've moved around a little bit, but
Yeah.
I did spend about 2 years in the Netherlands. And
Mhm.
after grad school, my first job was teaching at a university in the Netherlands. And you get to see when you know, move other places, how things are different. And one of the things you've seen those little smart cars, right?
Oh yeah.
Yeah. So there are no monster trucks in the Netherlands. I can't say definitively that they have absolutely zero, right? But I never saw one. Almost all the cars that I saw on the road were approximately like a little smart car.
Yeah.
And mostly people rode their bicycles, even in the dead of winter. I can tell you that I have a tremendous amount of respect. There was this Dutch lady, and I don't know if you know what the Dutch, but think Viking. You know, they're the tallest people in Europe on average. So these, this big strong lady, and she's riding her bicycle, and it's like 20 degrees below zero outside, and she's got a baby, like a 3 or 4 year old, like in a little seat behind her,
Mhm.
and she's got another like 2 year old on her handlebars and in a little seat, little helmet, and then she's got these two like saddlebags on the side in the back, with groceries in them. She rode her bicycle to the grocery store with her two kids in minus 20 degree. And I'm like, wow, like total, as I'm driving by in my car, which I imported from California. So it was not a tiny little car. And I'm driving by in my car. She's riding, in, the dead of winter. It's snowing, rain, ice
Yeah.
rain outside, minus, like I said, super cold. And I'm right next to her. I'm like, how can she do that? It's just incredible. And then I'm like, oh yeah, well, she's got a dress on, right? I'm like, oh, it's because she's got like these like thermal leggings on, because her legs from a distance look kind of like bluish gray. And I think that she's got like you know, Lululemons on or something, I'm like, so she's keeping warm. But no, I get closer and her legs are that color because it's so cold outside. She's not wearing any like stockings or hose or anything like that. She's just riding.
Oh my God.
Yeah. So people do it differently. And it's true. They have universal health care there. While I was there, I was taken very, well care of. I got sick a couple times, went to the doctor, went to the pharmacist, never paid a copay, got my prescription, boom, 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 done out. It was great. But
Mhm.
they don't have many PlayStations. they, I don't know. There are lots of people walking around with the iPhone 11, and there are no monster trucks. So, the resources are being spent differently. To get to your point about elasticity, the only thing I want to say is that elasticity has to do just with the responsiveness of the quantity demanded with respect to a change in price. So if it's inelastic, that means that when the price changes a lot, the quantity demanded doesn't change very much. And you're right, for goods that are what we would call necessities, they tend to have very low elasticities. They tend to be inelastic. So again, if you
Yeah.
change the price of insulin, it doesn't change the quantity demanded of insulin very much. And then, yeah,
Mhm.
eventually, if the price goes high enough, then like we're talking about, people just can't afford it anymore. Um, and so I don't know that at that point in time the elasticity really changes. It's just, there are still people that can afford it and are diabetic, and their quantity doesn't change very much. So in the overall market, I haven't seen that, at particular price levels suddenly, elasticity changes, but it might be the case. But for most goods that folks purchase, like I don't know, is there anything that you kind of like, um, um, I call them creature comforts. They're things that you buy that you don't really need that you like. So for me, I'll give you my example. I went to Target yesterday, and
Mhm.
and actually I'm a big fan of sparkling water, and pretty recently they started making sparkling waters that have very interesting flavors. So I bought this sparkling water, bubbly, 0 calories, and
Oh.
and it's cherry flavored bubbly, and I love it. It's like so good. And do I need to buy bubbly? No, I just do because I like it. And I also got some hummus that had artichoke mixed in it, and I like artichoke hummus. Very yummy. But for goods like that, which are a lot of the goods that a lot of people buy, they're substitutes. And
Mhm.
so, if bubbly got expensive, maybe I'd buy some other sparkling water that was flavored like Spindrift or one of the other ones that they have. Um, and so when consumers have, things like clothing and food and lots of different types of goods and services that we buy, there are lots of options. So, in that case, yeah, those goods tend to have pretty high elasticities because people will just switch around between them. Okay.
Yeah, that makes sense. I was just thinking about that because like I was like thinking about the insulin problem, and I was like, hold on, like I just thought of that in my head. That's why I wanted to ask.
Yeah, yeah, it's a good question. So, I wanna talk a little bit about preferences now. So we know what's affordable, what's not affordable. We know how the budget set can change. And instead of talking about um, um, instead of talking about consumers' utility functions, because we know that if your preferences are rational, they can be represented by utility function. Um, I just want to talk about preferences more generally first. So rational preferences, remember, they're complete, monotonic, and transitive. And I want to talk about monotonicity because this actually gets us, um, close to where we want to be. So, so we said we want to solve this consumer optimization problem. We want to know what the consumer is going to purchase. And actually, to be clear about it, we've actually done a pretty good job. We know the consumer won't purchase anything they can't afford. They could purchase anything in here, but we can make a simplifying assumption by saying there are only two goods available to the consumer. Now, when economists do this, they often assume that consumers are going to exhaust their budget because they say, well, they just have to buy X or they have to buy Y. And in that case, they're going to end up with some consumption bundle somewhere on the budget line. And we don't know which one, but look, we've done a much better job. If we know, oh, I'm trying to just move this. I don't know if it's going to let me, oh, no, it's not going to let me move it. Well, okay. I'm going to shrink it now. Okay. So if we know that the consumer has to spend all of their budget because they only have two goods to choose from, then we know that they're going to end up with some consumption bundle somewhere on the budget line. We just don't know which one, but we've done a lot better, right? We're no longer completely saying, well, anything in this consumption space, we say no, they have to be somewhere in this affordable set, which includes a budget line. And then we say no, they have to spend all of their money. Now we've got it down to this one set of points, which is described by the budget line. Okay. So we've done a lot better, right? we still have an infinite number of choices because there are infinite points on this line, but it's a smaller set than this bigger consumption set or even this affordable set. Now, it depends on how you define the goods. So I guess I'll talk with you again really quick, Sonica, because we want to wrap this up, and you were
Yeah.
chatty. So if I define the goods as being, X is cherry bubbly and Y is hummus that has artichoke in it, then that probably doesn't seem very realistic that I would spend all of my money on those two goods, right?
Yeah.
Because you're thinking, well, there's got to be like other goods out there. There can't just be cherry bubbly and artichoke hummus. But normally, right, we abstract from that when we're doing these simple problems. We say, no, 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 no. Yeah, we're in a universe where the only things that exist for consumers to buy are cherry bubbly and artichoke hummus. That's just it.
I wish life were like that.
Yeah. Well, I mean, you might get bored after a while, right? Artichoke
Yeah.
hummus and cherry bubbly. I mean, you'd be good for maybe a week, but after that, you'd get bored. But I want to let you know, even though the simple problems like the ones you'll see in Ignithium are tacos and tequila, right? Those are just supposed to be sort of comic, simple examples, and you're just supposed to accept that the model makes you have to spend all of your money on one of the two goods or the two goods that are available. But
Mhm.
in a more realistic sense, what normally happens when economists are doing this in practice is they'll define just one of the goods, like cherry bubbly, right, as being X. And then the other good will be everything else. It's what we call a composite consumption good. So in reality, when economists want to do this, they'll define Y as being, and these are the two phrases that you should introduce to your vocabulary. Composite, and I don't know if you're familiar with that term, but it's like from, material engineering. It just means joining together of a bunch of
Yeah.
other stuff in unspecified proportions. Composite consumption good. And the other phrase, this or term is a French word, numeraire. Okay. And when a good is a numeraire commodity, then that means that its price is defined to be one in terms of money units. Okay.
One in terms of money units.
Yeah, so it could be euros or dollars, but in our case, we would say P of Y by definition is going to be equal to $1. And then
Okay.
everything else is priced relative to that good. So if we're going to do this analysis, if you were an analyst for the Poultry Society of the United States, you would have P of Y would be everything else that consumers can spend money on, and the price of that would be one. And then you would be analyzing how much of their budget they spend on poultry, chicken, right? So even though I just wanted to bring that up because a lot of times when students are doing this, they're like, this isn't very realistic because tacos and tequila, who spends all their money on tacos and tequila? And it's just something for us to talk about, right? But in reality, yeah, the assumption that consumers are going to exhaust their budget is pretty common in practice, but it's only because you define the problem in such a way that you have one good that you're interested in, like poultry, and then the other good is everything else. Okay.
Yeah.
So
I
go ahead.
get why they use tacos and tequila or just like one or the other because it's easier to understand this whole budget constraint and consumption bundles when you're only comparing 2 items compared to 1 item and all items.
Yeah, right.
It's
So
easier in that sense.
yeah, these ideas like the numeraire and the composite consumption good, they're abstractions and they're very useful for real world analysis. But when you're first learning this stuff, it's easier to talk about tacos and tequila. So,
Yeah.
the only reason why I mention it is because this whole idea that you're going to exhaust your budget may not seem like a huge achievement analytically. It's kind of common sense, maybe, but in order to accept that that's a good prediction, you have to believe that the consumer really would do that, right? That they would spend all of their money on the only 2 goods that are available.
Mhm.
So yeah, we've gotten you know, a decent amount of the way forward with our problem. The other thing that I want to point out, and I have to draw another graph in order to do this. So I'm going to add one more screen, and okay, so this is the consumption space again. And I'm going to talk a little bit about preferences. Okay. And so let me go back to a bunch of pink dots. So these are a bunch of different consumption bundles in our consumption space. And then I'll do one that's different. Suppose the consumer is currently consuming at this orange dot. Okay, and let me see if I can make it. I'll make it a little bit bigger just because maybe that'll give it a little bit more emphasis. Okay, so the orange one is their current consumption bundle, right? And the consumer is rational. And remember, rationality means they prefer more to less, right? So what does more to less mean in this context? Well, in order to do that, you have to say, okay, at this consumption bundle, the consumer is getting a certain amount of good X and a certain amount of good Y, right? And so so monotonicity applies to each of the goods, okay? So it means that the consumer prefers more X and more Y, right? So what we know then is anytime the consumer can increase the amount of X or increase the amount of Y, they consider themselves better off. Okay. Is that clear, Sonika? Are you?
Yeah.
Yeah. Okay. So the question is, if the consumer could pick, consumption bundles, well, we would know that they would rank bundles down here. Oh, let me delete that and go back to circles. Would rank bundles down here, the green ones, right, as being of a lower preference, right?
Inferior compared to that other
Yeah,
one.
right. They would prefer the orange one over the green one.
Those green ones. Yeah.
Yeah. But what about this little dot over here? Well, this pink dot, right? It's got more X, but it's
Mhm.
got
Less
less
Y.
or less Y. So we don't know how the consumer would feel about that one, right?
I guess you could
It's
say that the consumer just like the orange dot is like the perfect amount that he or she would think is a correct bundle for them in terms of how much X and Y they want. And I guess all those pink dots, they're greater because like they seem great just because they have more of one, but it's not the perfect amount for them.
well, what
I
I want to emphasize, and I'll disagree with you, is so we just want to talk about, if the consumer is monotonic, what do they prefer and what do they not? Well,
Mhm.
monotonicity won't rank a point like this because relative to the orange one is where they're at. That's all we know. We know that they wouldn't like the green dots. They would prefer the orange to the green. Like you said, the green ones would be inferior. That's an okay word to use, to the orange one, in the sense that the green ones represent less of both. So monotonicity would rank the green ones as being less preferred. The pink one that gives you more of one but less of another good isn't ranked by monotonicity. So like this one wouldn't be ranked either. It's got less, again, we've got less Y and more X. And this one looks like actually it has a little bit less X and more Y. So this one wouldn't be ranked either. So I'm going to by monotonicity. So I'm going to go ahead and put um, another question mark here, there, and I'll put a question mark here. And the question mark just means that monotonicity isn't sufficient. And so this may be a meaningful idea. It's sometimes used in math. It's called a partial ordering. So monotonicity allows us to partially order the elements of this set, meaning the set of consumption bundles, the consumption space. So there's some that we can't order, right? We can't say
Mhm.
it's either better or worse. But notice that there are these points also, and I'll say like this one here, and it clearly has more of both X and Y, right? And this point has more X and Y, and this point has more X and Y. So they're going to be preferred to the orange point, right? So I'm going to go ahead and
Then wouldn't you say that that dot, like you see the the second one, not that one, the one next to it with the question mark, wouldn't that be considered more X than Y? So wouldn't that be okay?
which one, I guess, is, do you
The
mean
question
this
mark in
one
the
here?
no, the other one. Yeah, that one. Because I see it's more X than Y essentially. So that
Yeah,
would also be considered.
well, yeah, because relative to the orange one, right? This one has more X, right, but less
Oh,
Y, right? Because it's down here.
mm. Oh, so the other ones would be more preferred because it's like either slightly more X or slightly more Y. I
Yeah,
mean, both slightly
or
X,
a
more
lot
X.
more X and Y.
Yeah.
So what I want to do is I'll use this color. So I want to point out that we can draw this line, and actually I want to go ahead and move this one dot a little inside here, just so we don't have to worry. I'll just move it in. So we don't have to worry it's on the boundary. Okay, now move back there. So, okay. So what I want to point out is that what we know about all the points that fall on these lines, right, is that they have at least as much of one of the goods and strictly more of the other one. So again, you know, if I was to take a point, let's say here, that's right on the boundary, right? Another orange point. The orange point there, right? It's got more Y and just as much X as the original orange point, right? Do you see, Sonica?
Yeah.
Right. It's got more Y and just as much X. So all the points on these red lines, I'm going to say these boundaries, right? These represent the boundaries of the preferred set. Okay.
Mhm.
So let me see if I can do a good job here. So all of the points there are preferred to the orange point because they have at least as much of one of the goods and strictly more of the other good, or they've got more of both goods, right? So monotonicity allows us to look at each point and identify. And so, for example, let me try to get another color that'll work. So to look at each point. So for example, now, if I look at this point here, then I can draw another like rectangle here and see the preferred set for it. And obviously these preferred sets go out into infinity, right?
Yeah.
But they just have this like right angle where the dot anchors the region that's the rectangle that defines the strictly preferred set. And all I've said is that consumers are monotonic, right?
Okay.
So monotonicity allows me to order the set of bundles. So why does that help? Well, again, if I go back to the consumer and their budget, right, I can get back to this idea that I know, suppose a consumer starts out at some point in their affordable set. Suppose they start out there, they're purchasing this point. Would the consumer, you know, stay there, or would they move toward the boundary? Well, if I know the consumer, now I'm not just talking about affordability, right? And I'm getting back to this more to this issue of, well, the consumer is going to spend more. They're going to exhaust their budget. Why are they going to exhaust their budget? They're going to exhaust their budget because they're monotonic. Because again, if the consumer was at some point that's affordable, but they did exhaust their budget, then they would have all of these preferred points, right? And some of those preferred points would be affordable. So all of these in here are consumption bundles that are still affordable, but are preferred to the original consumption bundle. And notice that we can continue to make that argument until we reach some point on the consumer's budget line. Once we're at the budget line, right? If we're at a point on the budget line, then monotonicity doesn't help us anymore, because here the consumer's at this point there are all of these preferred points, but the consumer can't afford them. So we know if the consumer is monotonic, they will exhaust their budget. And so we're not forced to just say this random thing that seems irrational, like, oh, we're just assuming we're in a universe with only tacos and tequila. And we're just assuming that consumers are going to spend all their money on tacos and tequila because there are only tacos and tequila available, right? They can't save anything, right? We can replace that by saying, okay, we can see what's affordable for the consumer, and then we know the consumer is rational, whatever the goods are. The consumer is rational. And because the consumer is rational, the consumer is going to purchase more and more, right, until they can't purchase anymore. And so because the consumer is monotonic, we know they're going to exhaust their budget. It's because they're rational that they'll end up on the budget line. And that's all I have time for today. It's worth thinking about, like I said, but we're going to layer this on and eventually get a prediction of a single point on the budget line when we describe the consumer's preferences in more detail. So work on the consumption homework, and I will see everybody next time.
See you next time. Bye,
Okay.
Professor.
Bye. Does anybody have any
Hold on,
questions?
Professor.
Yeah.
I have a question real quick.
Okay, real quick.
Are we at some point, are the grades going to be released for things like